In this lesson, we're going to look at another reverse type scenario that comes up in these circle questions. So we've been given an arc length, and we're now trying to work out the radius. We've also been given an angle at the centre. So to start this question, basically going into your normal minor arc formula. To get a minor arc, you take your angle 120 degrees, divide by 360, and you times by pi d. The difference this time is we know what the minor arc is. We've been told down here it's 32. We also know what pi is. It's the diameter that we're kind of missing in this formula, and then we can get to the radius once we get the diameter. So if you fill in your minor arc is 32, and then fill your other information in as well. We know what pi is, and we really just are trying to work out the diameter here. Now the good thing about this is you can do all that in your calculator and get a number. If you type in 120 divided by 360 times 3.14, then that comes out to be this number here, 1.047. So essentially 32 is equal to 1.047 times the diameter. Now a wee quick thing to do, what times the diameter makes 32? Well, if you divide these two numbers, you'll get what diameter is. So diameter is equal to 32 divided by 1.047, and that gives you 30.56 in your calculator. Now how do you get the radius if you know the diameter? Well, you just half it and you get your answer, 15.28 centimetres. Another thing to notice is that 120 over 360 is a third, so it's really a third of 3.14 times the diameter. Okay, next example, same idea, find the radius of the minor sector AOB given the arc length of 15. Just do the same thing, so set up your minor arc formula. So to get a minor arc, you take 70, divide it by 360 and times it by pi d. Fill in your information. We know the minor arc is 15, so we put 15 here. And we know that pi is 3.14, so we'll write that in. Again, we're trying to find the diameter first. We can't go straight to the radius, but diameter will be found by doing some maths here. So if you work out that highlighted bit, 70 divided 360 times 3.14 in your calculator, write the 15 down again, write the d again, times d, and just that bit becomes 0.61 rounded. A bit of division to work out diameter, so 15 divided by 0.61. And that comes out to be 24.59, you can check in your calculator. And then, because we know the diameter, we can then half to get the radius. And that's it. This is very similar to the National 5 2014 paper. I'll just bring that up. The pendulum of a clock swings along an arc of a circle. Calculate the length of the pendulum, so the length of the pendulum is the radius here, and we'll be given an angle and we're told the arc. It's literally the same question, the same technique.